All right, so in class, you'll get a good visual today. If you're watching this on the line, you're going to miss out on the cool visual parts, okay? But today we're going to talk about navigation, okay? And specifically, how many people have flown on an airplane? Okay, all right? How many people have been in a boat or a canoe or a rowboat or something like that before? Okay, okay? Those are the two types of navigation things that we're going to have today. We're going to have planes flying, and we're going to have ships sailing. Okay, both of them. Okay, so like if I'm a plane. Okay, now don't mistake me for Jack at the beginning of Titanic, but I'm a plane. Okay, all right, I'm a plane and I'm flying. Right? What forces are acting upon me as my plane is flying? What forces? Gravity. Okay. Gravity is pulling me down, right? Lift is pushing me up, right? So hopefully lift and gravity are equal, right? Because if gravity is more forceful than lift, we're going down. Okay? And if lift is more forceful than gravity, we're going into space. Okay, so hopefully those are equal. Okay, what other forces are acting upon me? Wind. Wind is acting on me, okay? So, let's talk about that wind aspect of it, okay? I, as the pilot of Linzmeyer Airlines Flight 1, okay, am going to fly directly to the door, okay? You guys are going to act like the wind, okay? So how are you going to act like the wind? Okay, you're going to blow, right? Okay, ready? So I'm going to fly straight for the door. You guys are going to be the wind. Ready? Go. Uh-oh, I hit the board. What happened? The wind affected my flight, right? Okay? So if I want to land in Albuquerque, and we'll call the door Albuquerque. Okay? I just like saying Albuquerque. Okay? Right? So if I want to land in Albuquerque and the wind's blowing from you guys, right? What are my two options? If I just set the autopilot and just say, okay, we're headed that way, that's the way we're going to head, I'm going to end up way over in Phoenix. Okay? Right? So what are my options? I can correct, right? And I can say, I can shoot, instead I could aim for Daniel, right? And then that would then blow me by the time, boom, that I'm in Albuquerque, right? Okay? Or, have you ever been driving in your car and your tires are kind of a little bit old, and so your car pulls a little bit to one side, because maybe one wore a little bit more. So instead of driving straight, you're driving with a little tilt to keep it going straight, okay? So I could fly that way, right? I'd say I'd be flying. No, I'd be flying this way because I'd be going into the wind. Okay, right? Okay. So those are two options. Either way, okay, in terms of vectors, the plane's vector plus the wind vector is going to equal my actual vector. Okay? So whatever the plane is doing plus whatever the wind is doing is going to give me what's actually going on. And sometimes, like you guys were coming at a perpendicular wind, so it was pushing me off, right? What if the vector is from behind? Then what? It'll push me straight, but it'll make me go faster. Okay? If it's called a headwind, if I'm heading directly into the wind, okay, that's going to slow me down. Okay? If it's from the other side, front or back, it could speed me up, it could slow me down, and knock me off course a little bit. Okay? But no matter what, we get that. Okay? Now, remember, vectors are magnitude, oops, that should be a U, times the cosine of the direction, and magnitude times the sine of the direction, right? Okay, so that's one thing that we got to remember. Because we're going to say the plane is heading in this direction at this speed. Magnitude is speed. Okay? Okay? So we're going to have to find vectors. Here's the downfall with the finding vectors part. Okay? In directions, we'll put directions in red. Okay? North is 0 degrees, right? East is how many degrees? What? 90 degrees. South is 180 degrees, and west is 270 degrees. Now that's direction. What about trig? What's east in trig angles? 0. What's north in trig angles? That one's 90, right? What's west in trig angles? That's 180. And what's south in trig? That's 270. Do you see the problem? Why is that an issue that I brought forth? Why is that going to be an issue?
Because you're using trig functions.
Because I'm using trig functions. So to find my vectors, these are trig angles. Okay? If I'm going to use that magnitude times the cosine and magnitude times the sine, those have to be in trig angles. So it's like the song that we played before school today, the homeroom walk-up song. It's the circle of life. Okay? So we're going to start with a bearing or a direction angle. We're going to switch it over first into a trig angle. Then we're going to find our vectors in trig. Then from that, we're going to find the things that we need. And what we need is we need a direction in the end, so we're going to come back to a direction angle. Okay? It's a lot of logic, but you can handle it. Okay? So that's the couple of things that we have to remember. Okay? So let's talk here about a plane flying at as an airspeed of 450 miles an hour, bearing 150 degrees. The wind is blowing at a bearing of 60 degrees at a velocity of 50 miles per hour. What is the true course and ground speed of the plane? Okay. So, there it is. Okay. So let's first talk bearing. So let's talk the bearing of the plane and of the wind. Okay. So the plane has an airspeed of 450 miles an hour and a bearing of 150. Well, 0 degrees is here, 90 degrees is there, so that would put me at 150 degrees right there, correct? Yes? Okay. What is that in terms of trig? That's 150. That's 30. So my trig angle would be how much? Here's 90. Here's 180. Here's 270. I got to go 30 more. So my trig angle is 300 degrees. Okay. Hey now. Okay. Then, now we go over to our wind. Hey now. Okay. So now we go over to our wind. And our wind is bearing 60 degrees, correct? So that means it is going here. What is my trig angle? What is my trig angle? 30 degrees. Does everybody understand that switch over first? Okay. So now we can find the plane's vector. Oops. Wrong color. Plane was in green. Now we can find the plane's vector. It is going to be, what was the plane flying at? 450? 450 miles times the cosine of 300 degrees and 450 times the sine of 300 degrees. Give you guys a second to calculate those out. First one, what did you get? 225. Second one, what did you get? 0.711. Yep, okay. All right. Now we need to find the wind. The wind is blowing at 50 miles an hour with a trig angle of 30 degrees at S. Oh. So I get those two, 43.3 and 25 for my winds vector. Okay? Now, my actual velocity and direction is going to be what the plane is doing plus what the wind is doing. If this were a ship, my actual direction would be what the ship is doing plus what the current is doing. Okay? All right? So I have to add those two together. So that's going to be 225 plus 43.3 is going to be 268.3013. Negative 389.711 plus 25 is going to be negative 364.711. Okay? So that is what the plane is actually truly doing, the vector that it is. From that now, I can find what the plane's magnitude is, because magnitude is speed. So the actual speed is going to be 268.3013. Square that, add that to negative 364.711, square that, and take the square root of that sum. So that gives me an actual speed here of 452.769 miles per hour. To find my reference angle, I take the inverse tangent of 364.711. I drop that negative sign. 268.3013. And that gives me a reference angle of 53.6598 degrees. My question to you is, which quadrant is my actual plane in? The actual plane vector, which quadrant is that in? 4. It's in quadrant 4. So this vector right here is a quadrant 4 angle, or a quadrant 4 vector, excuse me. Okay? Now, thinking about quadrant 4, and in regards to, so that means I'm somewhere down in this direction, right? Okay? Now, switching back to bearing. What bearing, or how would I find the bearing of a quadrant 4 angle? No. 90 plus the reference angle for bearing. Well, you would for quadrant 4 for trig, it would be 360 minus the reference angle. But for bearing, because remember with bearing, 0 is here, 90 is here, and down here is theta prime, I'm going to go with 90 plus theta prime. Okay? So my actual bearing here is going to be 143.6598 degrees. Okay. I could have first found the trig angle and then switch that over to a bearing, but there's no need. We can jump right over that step and go right to our actual bearing. Okay? What I would like you to do now is I would like you to try this next word problem. So we are given two different parts. We're given what the plane started out doing, and then we're giving what the resultant velocity is. So that's its actual velocity. Okay? So my bearing of the actual plane, what it would, or the plane, what it was doing gives me a trig angle of 150 degrees. The resultant, the actual, gives me a trig angle of 145 degrees. Okay? So my, that jumped back up. So my plane here then is going to have, it's flying at 500 miles an hour. So that's going to be 500 times the cosine of 150 degrees and 500 times the sine of 150 degrees. So that's going to end up being negative 433.013 and 250. Yes? Okay. Then my actual is going to be 525 miles per hour with a cosine of 145 degrees and 500, oops, excuse me, that should have been 525. 525 times the sine of 145 degrees, which is going to be negative 430.055 and 301.128. So now my actual is going to equal the plane plus the wind, right? Which means my wind then would be the actual minus the plane. So that's going to be red minus green. Red minus green gives me 2.95788 and 51.1276 there. So that's the vector that I then need to work off of so then I need to base everything off of that. So the magnitude of my wind is going to be 2.95788 squared plus 51.1276 squared, and I'm going to take the square root of that. So that gives me my actual wind velocity at 51.2131 miles per hour. Now you might be off by just a little bit because you rounded. I didn't round when I was doing my calculations. Okay? Oh, that didn't work out. There's that one. Then I need to find my reference angle. That's going to be the inverse tangent of 51.1276 all over 2.95788. Okay, so that's going to give me a reference angle of 86.689 degrees. Okay, I'm in quadrant number 1, correct? Okay, this is a quadrant 1 vector. So that gives me an 86 degree reference angle. I need to find the bearing of that. So my bearing in quadrant number 1, theta, is going to be 90 minus my reference angle, because I want just the piece that's left over. And when I do that, 90 minus theta prime, I get 3. Oops, that's a bad try. I get 3.31103 degrees. Yes-um? Yes. Again, I draw your attention over to the sideboard. You have a test on the basic operations part of vectors this Friday. The word problems part is Monday. You have, as of right now, 3 worksheets or 2 worksheets and a book assignment that you can be doing.